Well, good evening, everyone. Welcome. My name is Jordan, and I'm the manager of online education at COSI. Thank you very much for joining us this evening for the 2021 COSI Science Festival. We're very excited to have you here tonight. As you know, the festival has moved from a 4-day physical event to an all digital format, May 5th through the 8th. On May 8th, we will continue virtually with at-home science activities, and we hope that you will share your activities, your experiences with videos and photos on using social media, using hashtag COSI SciFest. And of course, we want to give a big shout out to all of our sponsors of the COSI Science Festival, especially our visionary sponsor, Battelle. We certainly could not have done this without them. And if you would like to show your support for COSI, we have once again been nominated for USA Today's 10 Best Science Museums. We would love for you to vote to share your experience by voting at cosi.org/10best to help us retain that #1 science museum in the US. And don't forget that COSI is opening up to the public again for the first time. We are very excited to welcome all of our visitors back on June 3rd. So we're excited to see you back here in the building soon. It is now my great pleasure to welcome our guests today. Welcome everyone for our Simple Machines program. Thank you all very much for joining us. Good evening, Clarissa.
Hi, thanks, Jordan. Hi, this is Clarissa with Pickaway County Library, and I've got Sharon, the Youth Services Manager, here with me, and Megan from the OSU Extension. Today, we're going to be talking a bit about Simple Machines and coming up with our own Rube Goldberg machine and going through the steps of the engineering design process, different types of Simple Machines, and showing you our objective to turn the page on a book without using our hands.
Have you ever wondered what makes humans so successful on Earth? It's our mastery of tools and simple machines. So simple machines can be inclined planes, wheels and axes, screws, wedges, levers, and pulleys. Basically, simple machines are tools that make work easier. Easier and maybe a bit more interesting. Here we have the remote controller invention. So today's supplies list for our simple machine. We're going to be using a book, yarn or string, a paper clip, 2 rulers, a large cylinder container, a plastic or styrofoam cup, a small ball, dominoes or some wooden blocks, a toy car, a tissue box, tape, and a small flat rock. We also have to know the engineer design process because it's the pathway to inventing. The first thing we have to do is identify our problem. And our problem is how to turn the page without using our hands. But we also have to generate ideas before we start. And we do this by sketching. So remember our supplies, because we're going to have to incorporate that in our sketch. We also have to select the solution and then start building. It's really important to test out your solution and evaluate it. Can it be improved upon and remixed?
So we're going to pause here to give you a chance to work on building your own Rube Goldberg machine at your house. If you have any questions or difficulties with your build, feel free to type them in the chat box so that we can help you work through those. I'm going to take a few minutes to talk about my engineering design process. To start with, I needed to define the problem. For me, since I work in a library, it was going to be how to turn the page in a book. And of course, I could do that with my hands, but that's boring and you wouldn't want to watch that. So then I went to the next step, which was research. For me, that research was looking around our workroom, looking around our storytime room and figuring out what materials or supplies I had to use. I tried to choose things that you may have around your house, nothing super crazy. So that's how we came up with our supply list. Feel free to change your supply list or add more things to it to fit what you might have around your house. Then I imagined how I would use those items together. So kind of started in my mind's eye, figuring out what I would do with these items, what order I would arrange them in, and then I had to test it out. So to test it out, I needed to draw up a sketch of my items. Megan, you have the sketch, or I've got the sketch here. You can pull it up. Yeah. There you go. So I drew up a sketch of my items, and you can kind of see some erase marks here where things didn't quite fit in the order that I would want them to work out. So I changed them up a bit. And then I built my setup. Once I assembled my materials and laid them out, I tested them to see how they worked. And as you'll notice, the way I have my items laid out physically is different than how they were in the sketch, because how the sketch worked in my mind was not actually how the items functioned together in real life. And the only way for me to know that is to test it out. So I tested it out, and then I had to evaluate what did and did not work. I found my failure points and tried to find some alternatives. That took several trial and errors. We'll show you some videos of that later on. And then I had to improve and redesign the different parts of my Rube Goldberg machine to make it function the way I intended it to. And so for some of those, that meant moving the dominoes closer together or adding more of them, shortening the string on the ruler, repositioning where I had the cylinder and our book. Megan, did you have some video of our different trial runs you can show them? Or did you want to? It's up to you. as you can see, that took us several tries to get everything worked out and figure out what exactly we needed to change and what the ideal setup was. I'll say the bus going over the edge of the table is by far my favorite part. If anyone has any questions at any time, again, feel free to put those into the chat box, and Sharon or Megan will answer any questions you have. So let's talk about what is a simple machine. It's a tool that uses force to make work easier. Did our machine really make turning the page easier? Probably not. It was basically for fun. It was complicated, but it was fun. But that's the real purpose of a Rube Goldberg machine, is to accomplish a task in some really extra complicated, drawn out way for amusement. Let's move on to the different types of simple machines. I've got several examples here. I don't know if you can see our little toy car or our bus. This is what we use to start our chain reaction for our machine. And this would be an example of a wheel and axle. This one is a pretty common type of simple machine. And then I had it coming down an inclined plane. It was able to travel down this inclined plane much faster because it's got wheels, so less friction, versus if I'd have just tried rolling a block or something down the inclined plane. The bus is able to start our chain reactions by transferring its kinetic energy onto our dominoes. We can talk more about how it transferred the kinetic energy a bit later. For our inclined plane, it uses a change in elevation, and then gravity is helping to pull the bus down the inclined plane.
So Clarissa, we have a question as to why you went for a wooden truck versus another type of car.
That is a really good question. And again, that goes back to the engineering design process and my research. My research involved digging through boxes of toys to find what we had. And this was really the only vehicle we had that was suitable size. We had some plastic cars, but they were much too wide. They also didn't have a lot of weight to them, so I was afraid they might not knock the dominoes down, or they would fall off the ruler that I used. I have another setup on the other side of the room. I'll show you over here. For this one, I also used a wooden car, but you'll notice I switched the track. We can talk a bit more about that in the later half of the video, but again, another option if you have different materials around your house that we might not have here at the library every day. Any other questions? Okay, if you have any, just chime in and I'll have Megan or Sharon stop me. So go ahead.
Hey everybody, it's Megan. We had some questions on having the right amount of dominoes, and we had the car question, and we gave you a supply list. And it is okay if you don't have everything on that supply list exactly. We wanted you to have some materials to work with. That's the most important. And it's all about experimenting and seeing if metal cars work better than wooden cars, or if 10 dominoes work better than 5 dominoes.
And if you don't have dominoes, you could use Jenga blocks. Again, just find what you have around your space. That's a good question. So I'll go back to the inclined plane. There were a few different things that I tried for this inclined plane. I've got quite a large ruler on here now. I think it's 15 or 16 inches, but you could use a shorter ruler, but then you have to take into consideration how that change in the length of your inclined plane, making it steeper or longer, is going to affect the velocity at which your wooden car or whatever you use travels down the ramp. Can anyone think of some examples of inclined planes that maybe you've seen around your house or your neighborhood? Yeah, type it in the chat box if you can think of any examples of an inclined plane. I'll give you a hint. Many of you probably have them in your house. All right, stairs would be a good example of an inclined plane, ramps, zip lines, skateboard parks, even a roller coaster. Those are all inclined planes that you probably use, mainly the stairs and the ramps every day. You can change the slope, make it steeper, more gradual, and see how that affects the results. That can be something you experiment with, one of the variables you can change in your machine. The next part of mine is the domino effect. This is a part of our chain reaction. So this sequence counts as a single step in our simple machine, even though there's multiple dominoes used. As Megan said, the amount of dominoes will vary. Depends on the size of table you have. Our table's pretty small, so I didn't have a lot of room for more dominoes. Maybe you could make yours more elaborate, have them zigzag around the table. Maybe use something other than dominoes, whatever you have around your house. And the last thing on the tabletop is our ball. So in the video you saw, the bus comes down the ramp, barrels into the dominoes, dominoes fall down, and then they knock the ball down. They transfer that kinetic energy to the ball. It rolls off the table. So it has a change in elevation, change in velocity before coming down to the lower part of our machine. So then I have a cup on a lever. I'll shimmy around here. Or a cup on a ruler. This is a lever with our cylinder acting as our fulcrum. This would be a class 1 lever because the fulcrum's towards the middle. And then the load motion is on the side of the string with the paper clips. So when the ball drops down, well, that wasn't high enough. It flips over and turns the page. Some of you might be wondering why I have a small rock taped to the end of the ruler here. I don't know if you can quite see that in the video. And that's acting as my counterweight because I needed something to hold the lower end of this ruler down because the weight of the tape and the cup was enough that it was tipping my cylinder the other way. And the only way I discovered this was through testing out my design, because in my original sketch, I didn't account for a counterweight because I didn't think the weight of that plastic cup was going to be heavy enough. If you don't have a plastic cup like this at your house, you can use a paper bowl. That's what I ended up putting on the other setup on the other side of the room, just to see how that different size container changed our results and if it caught the cup better. We did experience that this plastic cup, after several uses with the heavy ball, started to crack. That also wasn't something that we anticipated or that I thought of when I was designing the original Simple Machines setup. So moving forward, I would probably do something different, which is why I use something else on the other one. Okay, I think I am ready to talk about Simple Machines around the house. If you want to show that video, or did you want to go to some, do you want to show that video? Okay, we're going to show you another video talking about Simple Machines. I'm really happy we've had some questions.
Yeah.
Can you guys see how many participants are actually?
Simple machines are an integral part of our daily life, from the tires and axles on your bike to the door wedge in your classroom. These tools are everywhere. Simple machines teach us about work, energy, and motion. Sir Isaac Newton defined our modern understanding of force and motion. These lessons cross both our science and our histories. Helping us understand the importance of work helps us understand the energy required to move an object, and it helps us understand what simple machines enable us to do. Lessons on Rube Goldberg's overlap the lessons on simple machines, making a Rube Goldberg machine a fun hands-on activity, but also it's a way of connecting us with really useful simple machines we all use on a daily basis. We promise that after today, you're going to start spotting simple machines everywhere.
Do you want to pause there?
You'll also
We can talk about maybe some. So I'm going to pause the video right there. We'll get back to it, but it mentioned that you could spot simple machines everywhere once you knew what to look for. So I want to take some time to talk about the different types of simple machines and maybe see if anyone can recognize some in their house or the room they're in. Different types of simple machines would be wheel and axle and levers. We've already talked about those in our simple machine. There's also pulleys, wedge, and screw. Wedge would be like shims used to level furniture or toilets. Is there anyone that could maybe, go ahead, Megan.
So Heather shared a car jack, which is an excellent example of a simple machine.
Nice, that's a great one. What about a screw? Can anyone think of a common screw type of simple machine that you would use in your house? You probably have tons of them in your kitchen and cabinets. How about a jar lid? Or screws used to hang your cabinets on the wall or build your house?
So Anne mentioned that a bouncy house is a simple machine, and she was talking about the slides that are attached. But in a lot of ways, the simple machine is also like a catapult design in the sense that if something hits it, it bounces back. There's a reaction, there's a force happening. So there's lots of things going on in bouncy houses.
Oh, that's a good one. I'm thinking if I was just sitting in the bounce house and say Megan jumped on it and sent me flying in the air. What about a pulley? Can anyone think of any pulleys they might find around their house? One that some older homes may have would be old windows with sashes, with the counterweights, or old garage doors, some of the older style used counterweights also.
And I'm sure everyone is familiar with the bathroom wheel, right? We use on a daily basis. If we didn't have the wheel and the axle, we wouldn't have the toilet paper roll.
That's a good one. The wheel and axle I was thinking of was a doorknob, but I would appreciate, toilet paper was very hot commodity last year. Inclined planes could be the pitch on your roof or ramp to your front door or stairs. Another lever would be like a bottle opener or your toilet seat, since we're on the subject of toilets right now. Or a double first class lever like scissors. I use scissors for quite a bit of this. Okay, anyone think of any other simple machines in their room they're working in or around their house? Okay, if no one else has anything to suggest in the chat box, then maybe we'll move on and finish our video.
Also learn a lot about the human history and the creativity in our societies and cultures as a whole that invented and used simple machines. The same physical principles and mechanical advantages of simple machines used by ancient engineers to build the pyramids are employed in today's engineers to construct modern structures such as houses, bridges, and skyscrapers. Moreover, simple machines are an invaluable tool for helping engineers solve everyday challenges. They provide mechanical advantages that make it easier to get more work done in less time. Construction and home improvement projects is another area that requires knowledge of simple machines. When building a home, simple machines like a wheelbarrow with a wheel and an axle are used to carry items. Even a doorknob is a simple wheel and axle machine. Screws are simple machines, as are shims and wedges used to install doors, windows, and cabinets. Levers in the home include doors, brooms, and toilet seats. Even mechanics need to understand simple machines. A car itself is called a complex machine, but it's comprised of.
So I wanted to pause here again. So a car is technically not a simple machine in and of itself. But if you look at this diagram, you can see that there's many different simple machines together in the same machine, working together to make a more complex machine.
Machine, but it's comprised of many simple machines within. Automobiles contain many standalone simple machines, like a steering wheel that consists of a wheel and an axle, while the shifting in the automatic cars is controlled by levers.
I'm not so good at those.
Consider a parking brake, which is a simple form of a lever. A car jack is another example of a simple machine. Even knowing how to drive a car, something that all young children aspire to do someday, requires understanding these simple machines. Tools like a bottle opener, a crowbar, a doorknob are all examples of simple machines and human force. Look around your home, your schools, your neighborhood, and start identifying simple machines all around you, and consider careers that use simple machines and complex machines that use the knowledge and the history and apply it to solve real-world problems of today.
Is there anyone that is still working on their build that cares to share how far along they are, or if they're having any difficulties? If so, share it in the chat box and one of us will get in touch with you and see if we can help you work through whatever issue you're having. After watching that video, can anyone think of any toys or games you might have around your house that use simple machines or are modeled after a Rube Goldberg machine? If you can think of any, type it in the chat box and I'll have Megan or Sharon read it to me. No. The two that I came up with were a marble run, which is pretty popular at our house, and Mousetrap. Mousetrap has you assemble all the different parts of a crazy contraption to catch mice at the end, and it's definitely like a Rube Goldberg machine. If you haven't seen that game, you might want to check one out. All right. Do we want to move on to variables and talking about improving our design? Okay. So I'm going to talk a little bit about the different variables that we tested out that you could see in that first video clip where we were doing the trial runs with our machine to figure out how to get it to work to make it turn the page on the book. Some of the things that we adjusted were how many dominoes we used and the spacing for those. As you could see in the first several takes, not all of the dominoes would fall down, or they wouldn't hit the ball with enough force to make it fall off the edge of the table. So we ended up putting several more in and moving them closer together. One thing that you could do is put a piece of paper or masking tape on your work surface next to your dominoes and draw a mark next to them and mark where your spacing was, and then adjust that. Maybe space them further apart or move them closer together, and put a second mark on your masking tape or your paper and write down, this is my second trial run. They're X number of inches or centimeters apart, and then you can record on a sheet of paper what your results were. Was it more successful or did it not work at all? The other thing that we changed was the position of our cylinder on the floor and the length of our string. Again, what you could do is take a piece of paper to the floor or a piece of masking tape and mark a line on the floor so you knew where to position it, and then move your cylinder further or closer to your table so that you can mark where you get the best results at. And then record that on a sheet of paper. So if having it 3 inches away is too far away, what happens when I move it back? And record your results. One thing I did not change that you might want to is changing the distance of the ruler from the center of my piece of tape. I have mine taped pretty close to the center on my cylinder, so there's about an equal amount of ruler on either side of my fulcrum here. You could try moving it further back and marking it on your ruler, or moving it closer to the front, and see how that changes. Does it turn your page more or less? And the same for your string. Do you need a longer piece of yarn or a shorter piece of yarn? And what does that change do for your result? So these were all part of our testing and redesigning, going back to that engineering design process. And don't get discouraged if yours doesn't work the first try, because it probably won't. So if you don't get it figured out and working the way you want it to tonight, feel free to take a break, come back to it, finish watching our program, and then maybe come back to it later this evening or tomorrow. And if you are successful, or even if you're not, feel free to share a video or a photo on Pickaway County Library's Facebook page. We always love to see what our patrons are working on and see that you are enjoying our programming and participating, and giving us some feedback on what you liked about it. When working on your own design, it is really important to document what works and what doesn't, and identify those failure points. The only way to change your design to get it to work is to figure out what's not working. Megan was able to help me through that, and our biggest failure point was not having enough dominoes. Not having enough dominoes to really hit the ball and give it enough force to get it to drop into the cup. Let me see. Okay, in that video, it talked a little bit about careers for the mechanically inclined. What all careers did you have in that, Megan?
So if anyone is bored, no matter how old you are, I think if you go to Indeed or Monster and you look at jobs online, it's a lot of fun. And some careers out there you'll never have heard of. But when I started exploring jobs with simple machines, I was finding a lot of great summer jobs out in greenhouses and production companies where they just had a lot of moving parts and things, and they pay really well. And so don't be afraid to go online. But there's also companies, I saw a lot of distillery jobs out there for folks when you get older that pay really well. And again, when you think about it, making a product requires a lot of moving parts. There's a lot of robotics and a lot of gears. And the way of the future is automation. And automation just makes simple machines do work easier, but it's automated through code. And so learning a little bit of code and computer science, as well as hands-on engineering, you're going to have lots of fun in careers that do things in those two areas.
Like a CNC machinist. It used to be if you were a machinist, you operated like a press that would machine the metal manually. But now a CNC machinist would design it on a computer and put your metal into a machine and it will plasma cut it or mill it for you.
Yep. So a lot of the simple machines that you're seeing were hands-on tools to make work easier. And when you saw pictures of the pyramids and they were building, they were simple things that humans put their hands on to do work. And in today's modernizing world, those hands are becoming robots and AI technology, but they're still moving simple machines around. It's just they're not being moved by the human hand. And so that's where coding becomes really valuable skill set to acquire.
So I took some time.
And I just want to throw out there too, because I know a lot of connected coding toys are out there, and Extension plays around with a lot of connected toys and Spheros. So don't be afraid to experiment after today. If you have a Sphero ball, you can code your Sphero ball to move and then hit an object that sets a domino effect and makes something like a Rube Goldberg machine. So you can mix technology in materials together.
Mix the manual with the robotic. Yes. And going back to what Megan said, don't be afraid to come into your local library and ask if they have any STEM toys or kits. Our library has STEM kits that are available for checkout. We also have lots of books. We do have some STEM toys that are available for you to use here in the building upon request. Sharon, can you tell me what those STEM toys are? Because I don't remember.
Well, we have the Makey, and we have little bits that are for coding, and we also have some for even our baby toddlers, a Cubetto, and it's very, very simple, and you just put little pieces down and it follows those tiles. And we have a Caterpillar as well for the little ones. So it's unbelievable what is really a STEM toy and how simple they can be and how much fun they can be to use. So feel free to stop in at the library and request those, and we will get them out for you and you can play with them.
We did also recently get some 3D pens that you're welcome to use here in the building. Also, like I said, we do have three STEM kits available for checkout? 5, okay. Oh, yeah, a total of 5. I think there was 3 available most recently here at the Pickaway County Library that you can check out when they're in the building to take home. And what are the age ranges for those?
They vary. So.
Okay, age ranges vary, but they do have an informational card in the kits that'll tell you what's included, and they're on different subjects.
And I want you guys to think that you're hearing a lot of different products and names, and a 3D pen is a really simple tool, right? And you can push out plastic or polymer and you can make shapes. But when you break it down into little pieces, you can use 3D pens to make parts that you then assemble to put together. And so if you're into like Mousetrap, that was mentioned as a game that is very similar to the Rube Goldberg machine, you could build your own Mousetrap with the 3D pen and slowly assemble your pieces. You can also use the Makey-Makeys and hook them up to copper wire and code and play with electronics. So you can mix and match a lot of these toys together with a little creativity.
One good thing with 3D pens is you can also create replacement parts for your vintage 1995 mousetrap game. So going back to the careers, I took a few moments to look up some different careers that you might find interesting if you like this type of science. I guess this would be more like physics. What were you going to say?
I just wanted to throw out there, since we're on careers, and there's a lot of space news because of the Mars expeditions going on. And in space, there is so many simple machines and engineers and careers out there that you can explore and play with. And the technologies that you can go to your local library and get the kids and start playing around, do it, because there's 3D printing machines in space, there's levers, there's wheels, there's axes, there's slopes, and they just get more and more complex, but they all start on a very simple foundational level with the simple machine.
And if your library is not open yet, most libraries have online resources like ebooks or Overdrive that you can check out a variety of books without leaving your house if yours isn't open or available for checkout right now, since some of you may be in a different location. So I found machinist, auto mechanic, mechanical engineer, plumber, and HVAC. These are more careers I was thinking that might be popular in my immediate area. Obviously, there's a lot more science-minded careers like Megan mentioned. These were some that I thought might be interesting, since our local technical schools offer classes in these that you can take starting in high school. They do have adult programs, but not everyone has aspirations of going to college, so I wanted to find things that appeal to a variety of people. Some of these have 4 to 5 years of on-the-job training and certifications. Like a CNC machinist, you would need a degree for, but the average salary starting out is around $45,000. That's not too bad. Auto mechanic, licensing and certifications, 2 to 5 years on the job training. Average salary starting out as of March of this year is $42,000. For a plumber, you can often take classes at the technical school like Pickaway Ross and then start an apprenticeship, usually 4 to 5 years. This is a high demand job. Starting salaries average around $55,000 a year. And you wouldn't have student debt, so that's also a plus. Looking at Pickaway Ross specifically, since that's in my area, they offer commercial carpentry, electrical technologies, engineering, machining and manufacturing, precision welding, auto repair, automotive technology, diesel and heavy truck mechanics, and outdoor power technology. Did you have? Okay. Before we run out of time, I wanted to talk to you about some books I found. I'm going to switch screens here. Of course, this is a library, so this wouldn't be fun without promoting some books. These are just some that were available for checkout when I was looking online from our consortium only. So there may be other books that I missed because they were already checked out, or your local library system may have others. I chose some that were a variety of age ranges, but that tied into today's science program. So if you like this, you might find these interesting. This one, Junk Drawer Physics. This is a favorite of mine because it uses things you may have around your house. I am really big in not spending money on a one-time science experiment. So things you have around your house is good for me. Junk Drawer Physics by Bobby Mercer. This one is more of a younger picture book. It is still a nonfiction, but it's geared more towards maybe elementary age. Got some pictures and a little bit of history on Rube Goldberg. Just a fun read to introduce the younger kids to Rube Goldberg and Simple Machines. Like I said, that one's juvenile nonfiction. Build your own chain reaction machines. I like this one, but it's heavy on cutting out cardboard, which parents may find a bit less enthralling because you'll be the one cutting out the cardboard. It's got lots of step-by-step with all the measurements and materials you'll need. If you shop on Amazon a lot, you probably have a lot of cardboard boxes. So maybe this is a good one. This is Build Your Own Chain Reaction Machine by Paul Long. And the last one is Crazy Contraptions, Build Rube Goldberg Machines that spin, swoop, stack, and swivel. And I think this one is by Laura Perdue. This one's got examples of a bunch of different types of machines, breaks it down by what type of simple machine they are, how they're used, and examples that you may see throughout history or around town. This one's not quite as involved as maybe the first one that I showed you, but I still like this one because it gave a lot more in-depth explanation into the types of simple machines and how they're used. I want to come back here and ask you guys if you would take some poll questions for me before we leave. I've got 3 questions. You should see a poll coming up on your screen right now, and I would love it if you would fill that out for us. First question is, I learned something new as a result of this program, yes or no? I learned that troubleshooting is part of the design process. I hope you'll say yes on that one. I learned that creating and engineering can be a lot of fun and they apply to the real world. If you would take a minute to answer those questions for me, that would be greatly appreciated. And I think there is a link that Megan wanted to share in the chat box. If you could open that link, it should bring up a separate browser tab and complete that survey for us. That would also be greatly appreciated. You'll need to open the link before the end of the program because once we close the program down, the chat box will close with it. I'll give you guys a minute to do those. And if there's anyone still working on your build or that has any questions, again, feel free to type those in the chat box so that we can get back to you. All right, well, it looks like your poll question is that completed? Okay. Does anyone have any questions?
So Megan here, I did put the survey link in the chat box. It only takes a minute. It's a really simple survey. It has smiley faces and frown faces. And if you just wanted to skim through the questions fast and get that done, your feedback is critical to the programming that we do here at the library and at OSU Extension. And I'm really glad that you guys decided to join on a Thursday night.
Yes, yes, we do appreciate the participation. It is a little bit challenging for us because we really enjoy in-person programming so that I can interact with participants directly. It's hard for me not to be able to see what you guys are creating at home because that's the fun part for me, but thanks for joining our program. And thanks to those of you who've typed responses or questions into the chat box, because that lets us know that at least someone's participating and enjoying our program. Got a few more little things in case anyone watching is from the immediate area, but not necessarily from Pickaway County. I looked into Lancaster High School Career Tech, and it looks like they offer a vocational program through their high school for auto technology, carpentry, construction tech, and industrial engineering. And then Eastland Fairfield Technical School near Groveport also has adult and high school programs for many of the same that I've mentioned before: welding and HVAC, ag and heavy equipment, automotive, construction, and some others. And then I have a couple links, but I didn't email those to you.
I hope everyone has visited Pickaway County Library's Facebook page and OSU Extension's Facebook. After tonight's show, we're going to load it up with some resources, and we'll also be able to share this night's recording with you if you wanted to rewatch it at all. But definitely go on social media. We'll post those resources for you.
Yeah, I've just got a couple of websites related to today's activities that you might find interesting, that have ideas for at-home projects you can do, similar, well, maybe not similar to this, but along the same lines with Simple Machines and Rube Goldberg machines. So I'll make sure that those get shared in the comments.
And we know that this virtual setup isn't ideal for sharing our Simple Machine designs. So please feel free to take pictures at home and post those to our Facebook page, because we would really like to see the inventions that you're coming up with. And so we're hoping that this show kind of just got you started in thinking. You have the supplies in front of you, you've been testing it out. So don't be afraid after we say goodbye tonight to continue playing around with those supplies and bring in some new supplies and make it more complicated, and share the pictures and the video feeds with us. We would love to see them.
Would they be able to email us, Sharon, if they had questions and wanted to follow up afterwards?
Yep, that's their youth manager.
Okay, so Sharon says if you have questions or want to just share with us after the program, feel free to email us. You should be able to find a youth manager email through the webpage for Pickaway County Library. I think we're about running out of time now. One thing that we didn't really get a chance to talk about, that we probably don't have a lot of time left, is what if I wanted to add more to my design? Ideally, I would have, but I was limited by the items we have here in the library, and I didn't want to take anything up the wall because I figured parents at home might not want their children putting holes in the wall, and I didn't want anyone sending a not so nice email. But if you have other things you want to add to yours, maybe you could come up with something that would hit your truck or your car to launch it down the ramp. Maybe some sort of gears or something that could turn something and kick it down. I don't know. The possibilities are endless and really just depend on how creative you are and what you can find around your space to use. But if you do add more things to your design, I would love to see them. So please do share photos, and feel free to stop into the library in person. We are open 7 days a week now. We're back to our regular hours. Patrons are allowed in the building. We just ask that you limit your visit to 2 hours and do wear a facial covering while you're in the building. Anyone have any final remarks?
No, we had some thank yous. Like I said, we had a lot of fun gearing up for this program and sharing some of the resources. And we hope you had fun tonight and gathered as a family. And we hope to see you in person really soon.
And thank you, COSI, for helping host this. And thanks, Sharon, for coordinating this. And thank you, Megan, for coming down to the library twice and helping me put this together.
Yeah, well, thank you for participating in our science festival. We're happy to have you. While seeing no further questions or comments, then I'm going to again thank our guests for joining us tonight and thank all of our participants for viewing at home. We hope you enjoyed the program and we look forward to seeing your finished Rube Goldberg machines. Again, we'd love to see those if you could share those using hashtag COSI SciFest, and again on the Pickaway County Library's Facebook page. We would all love to see those events. So thank you very much for joining us this evening, and we look forward to seeing you back in our building soon. Have a great evening.
I am happy they're reopening.
Bye, everybody.
Bye.